So here we are back in chapter 7, moving on to section 7.3, where we're going to start working with equations involving these trigonometric functions. So we want to learn how to solve equations involving a trigonometric function, a sine or a cosine. And we might do it analytically, like by hand. We might do it using a calculator. There's a certain very specific type of problem that sometimes gets thrown at students where it's in a quadratic form. And a real fundamental tool in solving all of these equations are going to be fundamental identities like trigonometric identities and the reciprocal identities. And again, we might use a calculator or a graphing utility to help us out. So let's look at number 1. We're starting off very gently. Is theta equals pi over 6 a solution to the equation 2 sine theta minus root 3 equals 0? What about pi over 3? So in this question, you're just asked, plug in this value of theta and check, does it work or does it not? So I'm actually going to use this first problem as a pause here and try this. Plug in those values of theta and see if they work or if they don't. Okay, hopefully we gave it a shot. So if you put theta equals pi over 6 into here, you get 2 times the sine of pi over 6 minus root 3. The sine of pi over 6 is a half, so you get 1 minus root 3, which is not 0. However, therefore pi over 6 doesn't work. But if you plug in pi over 3, the sine of pi over 3 is root 3 over 2, which will cancel out that 2. You get root 3 minus 3, which is 0, so therefore pi over 3 is a solution. So overall, sorry to flip back and forth. So overall, we found pi over 6 is not a solution, pi over 3 is a solution. All right, how can I solve the equation cosine of theta equals root 2 over 2? And specifically, find all solutions and then explicitly give 8 of them. Well, cosine is periodic with period 2 pi. So if we draw the unit circle, okay, root 2 over 2 is about 0.7. So we're looking for the cosine of theta, aka the x-coordinate, to be about 0.7. So down here I'm going to draw this line at x equals about 0.7. Remember, I have a radius of 1, so 0.7 is inside that circle. So you can see there are 2 angles in the standard rotation of the circle that will do this. Okay. Now, we already know that the cosine of pi over 4 is root 2 over 2. Okay. But we also could then go all the way around to this angle, which would also be, which would be 7 pi over 4, and would also have a cosine of 7 pi over 4 of root 2 over 2. So in one full rotation of the circle, we have 2 solutions, pi over 4 and 7 pi over 4. But notice we're supposed to give 8 solutions, and in fact, we're supposed to list all of them, which suggests that 8 isn't even all there are. And indeed, you can rotate around. So because the cosine function has period 2 pi, in one period, in one rotation, we found these 2 solutions. But then I can add 2 pi times any whole number and just rotate around k times. So rotating around once, you're adding 2 pi. Rotating around twice is 4 pi, aka 2 pi times 2. Rotating around 3 times would be 2 pi times 3, and so forth. So k is the number of complete rotations that you're doing in addition to the angle. So in one rotation, we found 2 solutions, and now instead of just doing this, you can go around, and instead of just doing this one, you could go around. So pi over 4 plus any integer times 2 pi, or 7 pi over 4 plus any integer times 2 pi will be all of the solutions. And if we just pick various choices, so if I do this first one with k equals 0, we get this. With k equals 1, we get that. With k equals 2, we get this. With k equals minus 1, we'd get that. Okay, k can be negative, doesn't matter. And for this second choice, if we do k equals minus 0, 1, or 2, we'll get these various solutions. Okay, it's not that if you were given, oh, please list out 8, it has to be these 8. You could, for example, just use this first form and let k equal 10, 20, 30, 40, 50, 60, 70, and 80. Fine, those are also 8 solutions. Okay, so now we're just doing a slight adjustment here. Can you solve 2 sine theta plus root 2 equals 0, but you're told specifically theta must be between 0 and 2 pi. So you don't have to find all of them, you don't have to list 8 of them. Just find however many solutions there are in between 0 and 2 pi. So what we want to do is solve for theta. So we subtract the root 2 and divide by 2. And now the question becomes, what are the angles in the circle whose sine is negative root 2 over 2? And I'll end up having to delete this, but we draw the unit circle. Okay, that's supposed to be the unit circle with axes that are perpendicular. That's such a bad drawing. Let me try again. I'm sorry. Okay, let's try this again. Here's a circle. Better. Axis. Axis. Better. Okay. So this tells me the y-coordinate is about negative 0.7. About down here. In one rotation of the circle, we get these two solutions. But notice, you might, for example, have a reference that says maybe this is negative pi over 4, but we need the angle to be in between 0 and 2 pi. So I don't want to consider this to be negative pi over 4. I want to consider it to be positive 7 pi over 4. And then this angle right here is 5 pi over 4. So those are going to be the two solutions we find. So let me remove my work. Okay, there they are, the two solutions in between 0 and 2 pi, 5 pi over 4 and 7 pi over 4. Now what if we took the same thing and it said find all solutions to 2 times the sine of theta plus the square root of 2 is equal to 0, and I want, how about negative pi over 2 to be less than theta to be less than pi over 2? So now we'd have the same basic picture because we have the same equation. Okay, so here is my line of about y is equal to negative root 2 over 2. Because we'd solve this and we would end up with theta is the arc sine, sorry, we would have sine of theta is negative root 2 over 2. So that's a y-coordinate, so I plot it down here. And we get these two angles, but now the restrictions have changed. We need theta to be between negative pi over 2 and positive pi over 2, which means this one is just excluded. It's not in between negative pi over 2 and pi over 2, no matter how I try to write it. And I don't want to call this 7 pi over 4, because that's way too big. Now I do want to call it negative pi over 4. So depending on how the restrictions are phrased and how many solutions you may or may not be looking for, you're going to find different things. So don't only focus on the equation, also pay attention to the restriction. So we'll do the same problem one more time. Solve 2 sine theta plus root 2 equals 0, which we already know is going to give us sine of theta is negative root 2 over 2. And now let's say that theta has to be between 0 and pi. Well, with the same picture, we get these two angles, and there are no first or second quadrant angles that will produce a sine of the sine of the angle being negative. So there are no solutions. So again, depending on how the restriction is phrased, the type of answer you're going to get is going to be very different. Okay, so that's it for this video. It's a quick little introduction to working with trigonometric equations. We're going to come back in the next video and do more examples, but notice what changes in this next example is that the argument, the thing you're taking the sine of, is not just theta anymore.